All right, so do you see on workbook page 3 how there's this?
Yes.
What we're going to jot is like a little cheat sheet. This is how you're going to find these things, and then we'll do some examples and like go back to this. So domain is the restrictions, and it comes from the denominator because your denominator can't equal 0. If your denominator equals 0, you get an error, which means it's a domain restriction. So always factor first, and after you factor, you want to set denominator equal to 0. And that'll give you like what x can't be, and you'll write your domain in interval notation. The range we're gonna look, the range is the hardest one, okay? And you're gonna look at two things. You're gonna look at the HA, which we'll do later in the notes, the horizontal asymptote, and you're gonna look at mins and maxes. Those are the two things that might impact the range. Might. Sometimes they don't. So the range, like I said, is kind of a crapshoot. Sometimes you can look at those things and it'll help you, but sometimes those don't help you either. All right, so range is kind of like a free-for-all. X-intercept, you're going to set the numerator equal to 0. And I'll also show you how to do it in the calculator, if you don't want to use these steps. All right, and just to show you like an example of an x-intercept, like if this was my graph, the x-intercepts are where it hits the x-axis. So if you're reading the graph, those are the places you're looking. The y-intercept, you're going to plug 0 in for all x's. Now if you're going to look at a graph, the y-intercept is on the y-axis. So you can, if you want to do it from the calculator instead of by hand, you can look at the graph. I'm just drawing random graphs, but like it's just where you're looking. The vertical asymptote is the same as the domain. You're going to do the same thing. You're going to set the denominator equal to 0. The vertical asymptote will create that like break in the graph, and that's where the domain is coming from as well. All right, now HA, there's 3 different options, all right? So when the top is linear and the bottom is squared, there's going to be numbers in front and there's going to be numbers behind, but I'm looking at like the x's, okay? I don't care if there's a number in front or not. Like if there's a linear x on the top and an x squared on the bottom, no matter what's after it, this one is y equals 0. Or if there's like a squared on the top and a squared on the bottom, I don't care what's after them. This one is y equals a over b, whatever the numbers in front are. The slant is the other option when it's like x squared is in the top and you have something linear in the bottom. You're going to do synthetic division. And you're only going to use the first 2 numbers. The third one you're going to cross off. This one is a linear equation. Y equals something x plus or minus something. Let me move that over, please. So when you do the synthetic division, you'll get a linear equation. That's your slant. And that happens when the x squared is on the top and the linear is on the bottom. If that's flipped, it's the 0. So it's all about the x's. All right, so you're going to have a bounded below if you have an absolute min above is an absolute max. I'm going to draw like a little picture with that. Where can I fit one? That one's bounded above. Or sorry, that one's bounded below. And that one's bounded above. Because it's got like a lowest point versus a highest point. There might be more than one curve, so just like a general picture there. To find the mins or maxes, you're going to have to trace them in the calculator. And these are the buttons that you pushed to get there. And then the end behavior goes with the horizontal asymptote. Obviously, these are all like cheat sheet rules that we could use, but I'm going to show you how to use the graph too, so that you don't have to memorize this, but sometimes for some people it's easier to memorize this. This is entirely multiple choice, but it's half of the multiple choice, okay? So it's a lot of the multiple choice. None of these are open-ended though, so if you have to guess, you'll have options to guess from, all right? All right, so there's 4 examples in your workbook. Here's the first one. What I did was, just to save us time, I hit y equals and I did the second alpha to get the fraction. And I just typed it into the calculator. And that's how I got the graph. You want to make sure you're using the second alpha button to get it in your calculator so it doesn't lose its format. So like, I'm not going to actually put it in, but like you want to use this, then this. Sorry, second y, alpha y equals. I was saying that wrong. Green button y equals, so that you get it in the fraction format. If by any chance your calculator doesn't do that, you can trade out with me on the final if you want, and I'll give you one that does, so you don't have to worry about the parentheses. I think yours you need to do. If you're okay with it, it's fine, but if you want to trade it out, you can. All right. So we get this. When you're doing this, you can do it from the graph or you can do it from the equation. If you're going to do it from the equation, you have to factor first. So I can't factor that, but this is perfect squares. So I can do like x plus 2, x minus 2. Do it underneath so we have more space. So I'll show you all of this from the graph, but I'll also show you from the equation. So my domain is what x cannot be. And that comes from the bottom, but it also comes from where the graph stops, where it takes the breaks. So you can see it's disconnected right here, and it's disconnected right here. Those are the 2 things x can't be. And those are coming from the denominator of the equation. X can't be -2 or 2, right? Because if x is 2 or -2, then you're going to get an error. So if my domain is everything but, I'm going from -infinity, which is over here on the left, and then I'm taking a break at -2. And the break is like a U. And then I pick up again still at -2, and I take a break at +2, and then 2 to infinity. So basically this is -infinity to infinity, and then you're breaking at the 2's. Okay, that is coming from the bottom. Now range, instead of side to side, is bottom to top. All right. You want to look for horizontal asymptotes, like places it levels off, or U shapes. There's no U shape here, but it does level off right here. Like this is a horizontal asymptote. And so there would be a range restriction there, except do you see how the graph goes right through it in the middle? Sometimes that middle part of the graph's not there, and now there's a range restriction. But for this graph, it never stops from bottom to top in here. just like one continuous motion. So there is a horizontal asymptote, but the graph goes through it. So there's no range restrictions, and that's all because of this middle. It goes consistently from bottom to top. So this would be negative infinity to positive infinity. If the middle of the graph wasn't there, and it was just these two sides, it would be negative infinity to whatever this horizontal asymptote is, horizontal asymptote to infinity. And we're going to figure out what that is later, so we would know. But because the middle's there, and it goes through the horizontal asymptote, we just go negative infinity to infinity. Now, in terms of the x-intercepts, you can do it from the graph if you want, if you know what an x-intercept means. An x-intercept is when the graph hits the x-axis. So this is the x-axis, this is the x-intercept. So you can read that point from the graph, it's 0, 0. Or you can set the numerator equal to 0. So solving that equation will also get you an x value of 0. So as long as you know what it means, you can read the graph or do it in the calculator. Y-intercept is up and down, so when the graph goes up and down, on the y-axis it's also intersecting here. So the y-intercept 0, 0, 2. Another way to get it is to plug 0 in everywhere there's an x. And I end up with 0 over negative 4, which is another 0, 0. Vertical asymptote is the domain. They're the same thing. X equals negative 2, x equals positive 2. It's this line that the graph isn't crossing over. And that line is coming from the restriction, and that restriction is coming from the denominator. So they pair. You okay so far? Maybe it's coming back. All right, horizontal asymptote slash slant asymptote. We're looking at the top over the bottom. And when the top is smaller, that's a 0. Or you can see that at the graph. This horizontal line is leveling out at 0 at the x-axis. So that's where that's coming from as well. If you want to read the graph to see where the level off is happening, or if you're using the equation when the numerator is smaller than the denominator. There's no U-shapes here. So there's no boundedness. I would need like an absolute min or max, and I need a U-shape for that. So there are none of either of those. The HA and the end behavior are a pair. So if the HA is 0, the end behavior is 0. But you can also get it by like extending this graph and seeing that it's just going to continue to level off. Where is it leveling off? 0. That's why this is 0. I chose the 4 examples that I did for a reason. They're the 4 graphs that you're going to see. So like you're going to see a graph that looks exactly like this. So maybe you'll remember this conversation when you're taking the test, all right? So that's the first one. This one's the second one. I'm just showing you how I typed it into the calculator. I did the alpha y equals, so I got it in that form. So we can use the graph, but if you're going to use the equation, you want to factor it. So I'm just factoring out a 4x, and then I'm doing perfect squares on the bottom. So what can x be? Negative 5 and 5. So I'm going to take that same domain from before, but instead of the 2's, I'm going to put the 5's. Now the range comes from 2 things, at horizontal asymptotes and mins and maxes. This graph has both of those things. So I'm going to skip the range until we actually figure out what those 2 things are, and then I'll go back to it. All right, x-intercept. There's actually 2 of them. It's when the graph is crossing the x-axis. You can read them from the graph. It's 0, 0, and I think 1, 2, 3, 4, 0, or maybe it's 3 from the graph. So if you want to read the graph that way, or if you're solving it by hand, we're setting the two numerators. So it's 3 equal to 0. But if you're taking the test and you forget how to do it, look at the graph and just read it. You can see it that way. So I've got a 0, 0, because when I solve this one, I get x equals 0. And when I solve this one, I get x equals 3. So 3, 0 is the other one. And the y-intercept is this one, because it's up and down. And here's the y-axis, and we're crossing here. So that's the 0, 0 one. And that's how I'm getting it from the graph, but from the equation, I could put zeros in all these places. And I ultimately end up with 0 over negative 25, which is 0, 0. These are the same. So if you have restrictions at negative 5 and 5, you have asymptotes at negative 5 and 5 as well. Four x squared over x squared. All right, the first term. The x squareds cancel out. So the horizontal asymptote is 4. You can see that right here. If you like dash this over, this level out area at the top is 4. And once I do that, I also do this. The horizontal asymptote is the long term, the end behavior as well. Now you see how that U shape is a maximum because it's an upside down U. Would you consider that an absolute? Is the top of the U the highest point on the graph? No. There's all this graph up here too. So it's called local. If there's not an absolute max, then it's not bounded. If there's not an absolute min, then it's not bounded. Yes, that's a maximum, but it's not absolute, so this would be not bounded. And then to find that min and max, I traced it on the calculator. So I just have a screenshot of what I traced. But you would do like a second trace, and in this case, that's a max. And your calculator will say right bound, so you'll make the cursor blink somewhere over here. Left bound, you'll make the cursor blink somewhere over here. Enter will give you the middle value. So I'm going to call it like 1.67, comma 2/5. Your calculator might give you decimals instead of 2/5. That's fine too. Just write it as the decimal. I think 2/5 is like 0.4. So it might give you like a 0.4 instead. All right, so range. Starting down here. We'll call this negative infinity. It goes up until this U shape, and then it takes this break in the middle. This U shape has a Y value of 2/5, or we'll call that 0.4. Range is the Y value, so I want to look at the Y value of that. Then it takes a break and picks up again right here. This is the horizontal asymptote. We figured that out to be 4, and then it goes up. So my range is going to be negative infinity to the negative point, or sorry, that's a positive 0.4. Negative infinity to 0.4, and then there's this break, and then it's 4 to infinity. Now what you'll see is I did a bracket with the 0.4 and a parenthesis with the 4. The bracket for the 0.4 is because that's a maximum. It is a point on the graph, like this point is an actual dot. Whereas this 4 is not a dot, it's an asymptote, so that one's the parenthesis.
Miss Diamond,
What's that?
for the test, say we don't use a bracket and we use a parenthesis, isn't that points off?
It's not, because it's multiple choice.
Okay.
So I'm not even sure if
It's just
it
like
gets
the
into that
focus.
much detail. Like, I don't think that one has a bracket and one doesn't to try and trick you. Like, I think they're just all different numbers.
Oh, okay.
So it's more focused on what the numbers are rather than the
The
bracket,
symbols.
yep.
Okay.
None of these are open-ended. Everything I'm showing you today is from the multiple choice section.
Okay.
And I'll show, like, once we're done, I'll show you the example problems of what they'll look like. It's not like your multiple choice isn't finding all of them.
Mm-hmm.
It's like, what's the domain of this one? What's the horizontal asymptote of this one? It's just specific parts.
Okay.
All right, so that's the second type of graph. So you're going to see a graph that looks like that in your multiple choice. You're going to see a graph that looks like that. And you're only going to be asked to find one of these things. We're doing all of them just to practice, but you're only going to be asked to find one. So here's what another graph will look like. This is I think it's on the next page, but it's this example. Now I'm going to show you how to use the graph, but if you're going to use the equations, you've got to factor it first. So here's what it looks like in factor form. So domain, what can't x be? X can't be 2. So it's only going to actually be 2 intervals because I'm only breaking at 2. Do you see any horizontal asymptotes, like a horizontal line leveling off? Straight horizontal, this way. I don't see one of them. Do you see a min or max, like a U shape? If you don't have a horizontal line or a U shape, then your range is everything. Those are the two specifics you're looking for. A U, I don't have that. A horizontal line, I don't have that. So then my range is just going to be everything. The graph goes from the bottom and never breaks as it goes up. Right? It's fully connected through here. It's fully connected through here. No breaks. That's my range. All right, x-intercepts, you can do it this way. Like this is an x-intercept and this is an x-intercept. So if I don't want to use the equations, I can just count the little tick marks and figure out what they are. If you're going to use the equation, you're setting the numerator equal to 0. That's where these two are coming from. And it looks like my y-intercept is right here, which is 0, 10. It's like the top tick mark. So you can see it in the calculator where the graph hits the y-axis, or you can plug 0 in for all of the x's. So 0 squared minus 0 minus 20 over 0 minus 2. So it becomes negative 20 over negative 2. But you can also read that from the graph. These go together. So if I have a restriction at 2, then I have an asymptote at 2. Would you say that this is bounded?
No.
No, I've got no mins or maxes or anything like that. So I'm just going to write that they're not there, right? This one's going to be a slant. Because when I do x squared over x, it ends up being a linear line. Like one of the x's cancels out, but I still have an x. Whenever the top is quadratic and the bottom's linear, that's when you have to do synthetic division. Right, I'm doing opposite of the bottom. And I'm going to do the coefficients of the first two terms. So it was 1x squared minus 1x. I don't care about the minus 20. That's just going to give me the remainder, and I don't need the remainder for the graph. So to do the synthetic division, you bring down the first number. So in terms of my equation, I'm going to have a y equals 1x, or just x. And then you multiply these. 2 times 1 is 2. And combine these plus 1.
Could you just do x plus 1?
Absolutely, yep,
Okay.
x plus 1 is totally fine. So what that means for the end behavior is these go hand in hand, right? But I can't put numbers here because this is an equation, and you can't write an equation here. All right, but think about the equation x plus 1. It's a linear line, all right? The left-hand side, the negative side, goes down as you continue to go left. The right-hand side goes up. A slant asymptote always has infinities as the end behavior. A horizontal asymptote is a number, 0, 4, 2, right? So if you have a horizontal asymptote, your end behavior is a number. But if you have a slant, your end behavior is the infinities. And that just depends on the graph, but I'd say 98% of the time it's negative infinity goes with negative infinity, positive infinity goes with positive infinity. It typically pairs like that. So that's if you have a slant. All right? So that's the third of the 4 types of graphs. So you're going to see this type, this type, this type, and then this is the last one. All right? I call it like the bird wings. It kind of looks like a bird flying. All right? So for this one, I go to factor. I can't factor the top or the bottom. It's not factorable. So if I can't factor the bottom, what do you think that means for mine? What x can't be? Well, if I set the bottom equal to 0, let's see that. I see where you're saying -2, right? If I subtracted the 2, how would I get rid of the squared?
Square root?
Can you take the square root of a negative number?
No, I.
So I, okay? So I can't factor it and I can't solve it. So what do you think that means for the domain? It's negative infinity to infinity. It's everything. There's no breaks in this graph. It never stops. So I'm just going to say it's everything. Now, in terms of range, I see a horizontal line right here. And I see a min or max right here. Both of those things will affect the range. This graph is only happening from here to here. It's just one little interval. So I have to figure out what that little interval is in terms of the y value. So I'm going to come back to that after I find those two things. All right? So x-intercepts. You can read them from the graph, or you're setting the numerator equal to 0. We're actually going to skip this one. You would need to use quadratic formula for that. It's not that deep on the test. All right? It's on the graph if it's there. So like, you'll see it in the graph, or you'll be able to factor it. You'll be able to solve it with a linear equation. You don't need to use quadratic formula, so don't stress about that one. Y-intercept is up and down. On this axis, I can see that one, I think. Looks like it's like -2.5. Oh, yeah. Make sure you stay. All right. If you don't want to read it from the graph, you're just plugging zeros in. 3 times 0 squared minus 5, 0 squared plus 2. So it ends up being -5 over 2. Or -2.5. If this is your domain, then that means that there isn't any vertical asymptotes. There's no breaks, then there's not vertical asymptotes. This is your HA. You can use the graph. I'm crossing at 3 there. Or you can use the powers. Now, how would you say this is bounded?
Below?
It's actually both. Someone said above and below. Below, yes, because of this.
That's a point. And
That's a
above
point.
is still
Above,
below.
because of the horizontal asymptote, it's restricted between there. Usually it's just one or the other. It's pretty rare that there's both, but this one is both. Above because of the asymptote, and below because of the absolute min. that green point is also an absolute min, and I just showed myself tracing it. When you trace it and you get something weird like that, it's 0. That's like a lot of zeros, e negative 6. So it's 0, negative 2.5. And if the horizontal asymptote is 3 and behavior is 3. Now, in terms of the range, it's going from the y value of this bottom point, which is negative 2.5, to the y value of the horizontal asymptote, which is 3. So it's all the stuff between negative 2.5 and 3. But 3 is an asymptote, and negative 2.5 is a point. So that's the bracket versus the parenthesis part. All right, so the practice, if you want to do it, it's totally up to you. But the practice that looks more formatted like your final is on page 5. I don't have multiple choice options, but I have it broken down into like the pieces that the multiple choice will ask you. So one of the questions says, what's the domain and range? Because one of your multiple choice asks you for those 2 things. One of them asks you about the boundedness, because one of the questions asks you about that. Does that make sense? The answers for these are posted on Canvas. Number 1 is not this stuff. So if you want to skip number 1 for now and just focus on what we did today, it's 2 through 7. And then the answers for 2 through 7 are on Canvas. Like I said, so that's 2, 4, 5, 6, 7. That's 5 multiple choice questions. It's about, I think maybe there might be a few more, but the multiple choice makes up a very decent chunk of this test, like this type of multiple choice. So let me know if you have questions. Otherwise, the rest of the time is yours to answer keys on Canvas if you want to check it out. If you want me to go over any with you, I will. Sean, you'll see this again. Seniors, you won't. So hopefully the refresher helps.